Today we are going to join Alice in this new adventure to the world of pods and high-order functions. So who am I? I'm Roksolana. I work as big data developer at Captify, and it's a British company with a department in Kyiv, and we build a product in the sphere of programmatic advertising. So in my daily work, I work in Scala programming language mostly, but I used to work in Java a lot before. Also, I'm Women Who Code Kyiv data engineering lead and huge Kubernetes and functional programming fan. So let's join Alice on this adventure. Maybe many of you know that Alice actually is a very adventurous girl, and she is very curious about things around her. So sometimes her curiosity leads her to some epic discoveries of the new world. And this time she was just visiting her granddad, and in one of the rooms of his house she has found this weird smooth object which looked like a screen. So she decided to explore it, and she just touched it and got sucked into it, because that's what happens to screens sometimes. And she was falling for a while in darkness until she reached the surface, and when she got up, she found herself on the lawn. And she could see the sign with these words, "Welcome to the world of pods and high-order functions." And that's when she realized that this is the beginning of her new adventure, and she was pretty excited, but at the same time kind of scared. So what these words supposed to mean? But she decided to step on this path, which led her to the entrance into the forest. And she could see at the entrance this label, functional forest, which sounded pretty mysterious as well. So she was walking for a while on this path, and she could hear some creatures somewhere around her moving, so until she even got scared, they just got out of the forest in front of her, and those creatures were the pods, which were the most simple creatures in this world. They tried to get acquainted with Alice. They kind of mumbled their names, Kafka, P-SQL, but Alice couldn't make sense of them. They looked like brothers and sisters with all these similar names, but she just didn't understand that. So the pods just got ashamed and ran away. But Alice just stayed there quite confused. So Alice continued her path into another part of the forest. And the trees in this forest looked a bit different. So Alice decided to look closer to explore the branches and the trees themselves. And actually, she saw that this forest is kind of alive, but it's not growing in a way. And also, these branches were actually the functors, because they kind of mapped to the tree itself, constructing those trees. So it was as well very weird for Alice, and she also saw that there are some flowers there, which were actually shimmering with some light. And some objects in this world are too complex to comprehend, like these flowers. And these flowers were the monads. And for her unprepared eye, they were actually very complex in structure. But Alice was not hesitating. She tried to look and look, trying to understand how these monads work, their structure. But that was too complex, so she just looked away. And at some point, she got out of that forest and saw that there is a river. And this river divided this kind of functional forest and some city. And she could hear already the noise of this city. So she tried to find some bridge to cross the river, and she has found one which was pretty almost broken, but she just was not scared of this danger, and she stepped on this bridge, and that's when she entered the default namespace city. But before that, there was another part of the forest, and it kind of looked more usual to her. But there was like something beyond that. So when she walked and walked, she could see this silhouette of the city, and something was very similar between these buildings. Actually, they were created out of kind of construction blocks, and all of them were different objects. And it reminded Alice of the constructor details. But the main features of this city were that they kind of constitute the type system. Each object, each building created its own type, but they were like kind of inheriting the base type. That's why they had more developed type system. And plus, some of the buildings, they had more similarities, so they probably mixed up with some other types, while the others didn't. Plus, they were immutable. So when a new building was created, it was actually a completely new object, and you couldn't actually mutate existing buildings and add up something to them because they would become something else. So in order to understand how actually everything works in this world, Alice followed to the heart of the city, which was the factory where all of the objects were getting manufactured. And in this factory, she could see that there were multiple mechanisms, like for creation of the objects and other things. However, some of them had the manuals, like trying to give the instructions to someone, and at the same time, others didn't. So she has found this, the mechanism of the objects creation in the default namespace city, and it was more closer to the Kubernetes nature of this world. So she could see that there is some command line interface called kubectl, by which she could issue some commands to it. There is an API server, which is a central management entity, and it just authorizes requests sent from kubectl. It helps to actually create objects, update them, and delete them. Also, there is an etcd, which stores all the events, all the metadata. Also, there is a controller manager, which actually checks whether our desired state of the system coincides with the real one. And there is a scheduler, which helps to schedule and create the objects in the best possible way in terms of resources. So Alice decided that she can explore the manual and see how actually the pods are getting created in this world, because she has already met some of them, and she could make sense how it works in reality. So she saw that following from left to right, she can just issue some commands through kubectl. It gets authorized by the API server. Then, if the command is fine, and for us it would be okay because the pods are authorized for the API server, the event is written to etcd, and then there is a controller manager that checks that we want to have 2 pods. But we actually have 0 for now. That is why it just hits the scheduler to schedule pods on the actual physical location, which would be anywhere in this world at that point. And also there is a kubelet which helps to connect the physical part with the Kubernetes part, actually define how these pods are going to run on the nodes and whether they are healthy and whether everything is going to be okay for their state. And also there is a channel built between these pods and containers. So this kube proxy allows all of these pods to communicate between each other and with the outside world. So that looked pretty complex, and it reminded Alice of the maze, because when you step on that path and you don't know the right turn, you don't know the right way, you have to explore step by step how you're supposed to move in this maze. But she already knew that at some point, by slowly discovering every part of this world, she can make sense of it. And sometimes in order to make sense of the world and to move on the path, you need a map. And she could find in this factory this Kubernetes objects map. In this map, there were simple objects like the pods, deployments, and replica sets. And she has found some of them she already knew, like the pods, but at the same time, she could get better understanding that there is a hierarchy, like the pod being embedded into replica set, which is more complex, and it allows to manage the number of pods, like replicas. Then it allows to build some volumes and so on. And there is a deployment, which has even more features, and it's and wrapping around replica set, which also contains the pod, so it's more like a hierarchy. And deployment allows some features like rolling upgrades and stuff like that. So she could already see that some creatures like deployments are more complex and they can do more than simple pods. Also, there is even more. There are daemon sets and stateful sets. And daemon sets, they just allow to run the pod, each of the pods on each of the nodes in some physical cluster or something like that. And they usually just for some utility purposes. Also, there is a stateful set, which allows to run applications which handle state, like databases. And also, they have features like ordering. For instance, the pods she met in the forest actually were stateful set pods because they have their names like something and a number because they were ordered. And this order helps sometimes to run some kind of rolling upgrades and stuff like that in a specific order if you want to. But there is more to it. This is like more simplified version because there are multiple kinds of services and volumes. For instance, there is a service for connecting inside of the cluster or outside of the cluster. Also, there is a volume which allows to store the data in various ways, whether it's cloud provider or something like that. Also, there is a job which runs only once until completion, and even more objects. But that was like enough to get the understanding that there is this special hierarchy. And she could see that in a way it builds a type system too, because these objects type are checked by the API server, and there is a set of types like pods, replica sets, deployments, and so on. So she could make a conclusion that the stuff she saw in the functional forest and the part of a functional nature in the city actually had this type system, and the objects like being part of this type system because they are checked for the type. And there is a part with the pods and deployments which also constitute their own kind of type system. So actually, like the river dividing these two worlds, which actually a bit like got into one another and coexisted with one another, was like a wrong division because they had this similarity. But not only that, she already knew about the forest, which is like not growing, but also the buildings which are created from scratch because they are immutable. So what about the Kubernetes side? Well, actually the objects there are kind of immutable because when you have to change something about, for instance, deployment, you roll it out and all the pods are getting created from scratch. So they are kind of immutable, but not in all cases. And also there is one more thing, declarative nature. And by declarative nature, it should be like explored more because it's this broad concept. So declarative nature here means that you have some kind of desired state of your system and you have an actual one. And usually you just say that I want this and I don't care how it's going to be rolled out, how it's going to be created step by step. I will just get the result and that's it. I don't care how it's going to be created in reality, like step by step. So for that, Alice decided that she can create this database which stores her knowledge about the world, the functional and Kubernetes world, and call it MagicDB. And all her knowledge like encompasses the stuff she learned already, like deployments, pods, stateful sets, volumes, and so on. And all of these concepts combined, and one of the requirements for such database for her would be to store this knowledge like as long as possible. So it should be kind of persistent. And in order to create this Kubernetes object, she had to use some kind of Docker image, and let's imagine that she will use some basic one, like basic DB, some version. And first of all, Alice decided that she can play a bit with imperative way, because like saying that declarative is better without trying out the difference would be totally wrong. So she decided to try the imperative way, and if in declarative way you don't care how it's going to be created, like step by step, in imperative way you actually do everything in a sequence and you have to control every step. And for her to help with this, she can use this kubectl. And she just tries a simple thing like kubectl run magicdb with the very basic image, basic DB, the version, and that's it. And with this simple command, she can get the deployment running and the replica set running. And it looks like this. She already knows this hierarchy, the deployment being easily rolled out with a replica embedded into it without even specifying this hierarchy. But also there is a pod getting created as well, because again, the same hierarchy with pod being embedded into replica set and deployment, and auto-generated name. But just playing with one pod is kind of boring, so she decided to create a few of them. So she just runs this kubectl scale deployment command on her deployment, which is MagicDB, and sets 2 replicas because she wants to see the two pods. However, there is one more thing, that declarative approach is one thing, like using it in creating objects and updating them. Another thing is that Kubernetes itself has a declarative nature, which means that even if you apply imperative approach, there is a declarative background in there, because when she runs this scale, she gets 2 pods, which means that there is a desired state for her, like 2 pods, and the actual one. And again, controller manager is responsible for checking that, the actual and the desired one. So she gets 2 pods getting created, and the one has been running for a while already because she just created it before, and the new one is created as well. But it's kind of just boring to run commands, so she decided to just purge everything after experimenting a bit, and she just ran kubectl delete. So the pod get into this terminating state, and here it is. They are deleted. So for Alice, it looks quite simple. Like, you just run kubectl scale. So what's wrong with imperative approach in a way if it's so simple to create objects, to update them? However, it's like a very basic example, and if you would use some kind of heavy database and more like setups for various applications you would want to use, you would have to create other objects like volumes and services, and setting it all up in a console view is kind of tedious. Plus, you would have to manage in a way some versions, because when you just experiment locally, it's you might not care how you change something. But if you do that for like your actual application on production and things like that, you would have to track the versions, like what you've changed and when, and you can apply like Git for that and so on. But in order to work with versions, it's better to use declarative approach. And for that, there is this like magic YAML file, and it's kind of Kubernetes DSL, or domain-specific language. It allows to set up everything for Kubernetes objects, for their options, and it's kind of a specific language, I would say, for Kubernetes. So Alice has found this template for the creation of these objects. So she just uses the kind of deployment again, because she just wants to compare the imperative and declarative way. And she can set up the name, which is MagicDB, and the labels. And labels can be used for searching some objects. For instance, if she creates more of the objects related to this deployment, she can easily find all of them by the labels, like labeling them MagicDB. Plus, it helps to connect those objects, but it's going to be explored later. Also, there is this section again with containers that she set up in imperative way as well, with some names she defined for it. And there are 2 more things which were not defined before. It's environment variables, and let it be just wizard for the DB user and a fairy tale for the DB name. So that's quite simple, and in order to run this application, she just hits kubectl apply F on this MagicDB YAML file, and here it is. Now the application works, and like she can see the same image. Deployment getting created, replica set. So you can pay attention that there is this tab desired, which is again about declarative nature, because we wanted to create one deployment, and it has a replica set and a pod, so we have this desired one, and the actual is the same. So it looks just the same as an imperative way. So the result is again the same, the pod getting created. So what's different? Well, creating a database, you would have to store this data for some time, and as one of the preliminary requirements was to store it as long as it's possible. And there are multiple types of volumes for that, but Alice wouldn't want to tie this volume to her experiment lengths. So when she purges the pods, for instance, she would want to still store this data for some time. So she decided to use persistent volume, which allows to store the data for a longer period of time without thinking if the pod will die, for instance, you will still have your data stored there. And in order to use this persistent volume in a more dynamic way, she could use just a persistent volume claim. Persistent volume claim allows to kind of say to Kubernetes system that I want to have this kind of volume, just give me this kind of volume, whether it exists or just create it for me. So it also has the same label as deployment, and spec part defines these characteristics of the volume, like the access mode to it, the storage type would be like 10 gigs for now, and other things. And in order to set it up for the deployment, she has to add this volume mount section with the name of the volume, some default paths in the container for the data, and more importantly, volume section. So there is a name, and usually if you would use this static provisioning of Kubernetes, you would have to define the specific name of the volume. But here there is this persistent volume claim, so you can set up the name of persistent volume claim, and you don't have to reference a specific volume. And this is how it's going to work in reality. So this claim is getting created, and the volume is created at the same time, which means that we didn't have the volume which actually answered our needs, like the same characteristics we defined. That is why it's getting created from scratch along with like persistent volume claim. And we can see that they are straight tied to each other from the beginning, and like all the characteristics coincide. The capacity that we set up, the access mode, and in a more like abstract way, it looks like this. We have our data stored persistently in a kind of safe locker. So if anything happens to someone accessing the data, or the persistent volume claim, which is in this case is more like a reference to the characteristics of the safe locker. Like this is the kind of data we store there, and these are like the sizes of data, but if something goes wrong and this volume claim is deleted or disappears, we still have our safe lock, and it still stores our data for a while. But more to it, there is also a possibility to define a service, as it was explored before, and this service allows to communicate with the outside world or like inside of the same namespace, but between different objects. So this kind of service can be defined with a name MagicDB again, and it's important to set up the labels here so the service would like directly reference deployment that we created. But there is a container part which is like opening to the outside world. This is the port by which it would be possible to connect to this service from some other service or other objects, and the name of this port, if it's like more comfortable to reference it by the name instead of the part. And in more abstract way, it means that we kind of have this port by which we say to the ship loading the cargo, for instance, this is where you can go, this is where you can load the cargo or like receive it. So it's like clarifying it specifically. Plus, in reality, when it's getting created in the Kubernetes system, the service is rolled out with the port being opened. Also, there is one more section that I've omitted, but in deployment YAML file, it also should be defined, the port. So it would be like possible to connect them to each other, because you have to open the port from the deployment side and service side as well. And there is the pod, and the service that was created is more like a bridge again to the outside world. But cluster API means that through this service, the objects can communicate only inside of this cluster. So it's like a kind of internal communication means. So there are like so many kinds of objects, and you have to decide each time what type of volume or service you want to use, like whether it's stateful set or deployment. So over time it can get confusing. Like, is there some kind of manual to define those? And obviously there are some best practices, but overall it always depends on the needs. So like the curve of learning may be quite complex in the beginning. And there is also a scaling part. So Alice already defined before that she wants to have like 2 pods, so now she can define even more of them. For instance, with declarative way, she can just add this part to the deployment description, replicas 3. And it means that she wants to get like 3 pods being created. And again, there are like the same labels, all of the same in deployment file. And now what we can see that one of the pods has like higher age value because it was created before, and 2 more pods are created. Again, like controller manager taking its part and saying that let's define 2 more pods. So this is the image Alice could see, the same like auto-generated names, which are also coincide with deployment names. So there is MagicDB and some numbers. And when she wants to define even more pods, because why not like see how it works if it's so easy to just change the number in the YAML file. So she sets just 6, and what she gets is actually like 6 pods, but again, one of them was created way before, 2 more were created a bit later, and the last 3 were created like in the end. But all of them have the same age because they were like rolled out at the same time. So just she can see that all of these pods are created and all of them still like reference the same thing. So now if she just experimented a bit with all these volumes, the services and deployments, so why not delete it and see how it works. So she kind of a bit cheated this time and created all the objects in YAML file, in one YAML file, which means if she just runs kubectl delete on it, everything would be purged. However, sometimes it's better to create various objects in different YAML files, so it would be like easier to manage them. For instance, recreate the service or some parts which you have to constantly change. So it wouldn't affect all the other objects in this YAML file. So when she just hits this kubectl delete, the service is deleted first. Then persistent volume claim is getting deleted as well. And then deployment is deleted. But both of these last lines means that along with deployment, a replica set is deleted as well as all the pods that she created because, again, they are kind of nested in one another. But it doesn't mean that persistent volume is deleted because, again, persistent volume claim only like references it. It doesn't influence this persistent volume in a way that it doesn't references its life cycle. So persistent volume still exists, and Alice would be able to still reference this data in the future with another claim she would want to create, or like manually by specifying the name. So it looks very easy. Just with one YAML file, a lot of things can be rolled out in one system, a lot of objects. So indeed, the declarative way looks more easier in more complex systems. So for Alice, like Kubernetes and functional way of seeing things are not that different because over like experimenting and traveling through this world, she could see that there are so many similar things in both of them, in both Kubernetes and functional way. So first of all, the type system. So type system means that there are, like, again, various objects which create this, which can be based on some type, and they can inherit it, or they can be mixed with one another. And in both like functional forest and the buildings in the default namespace city, these objects have this type system because they kind of create it. In Kubernetes, again, there are pods and deployments, and they are checked against the API server for the like true type of them. And so she can make this like conclusion that both of the natures, like functional and Kubernetes, they actually constitute this type system. Buildings being created from scratch, the weird functional forest So the objects there are definitely immutable. In Kubernetes, she could see that not that so, but partially yes. Some of them are immutable, and she can work like from scratch by creating these objects from scratch if they change and so on. Also, she discovered declarative way mostly on the Kubernetes side. So she could create objects with sending commands like imperative way, or with defining YAML file. So she already could make this more confident conclusion that both of these objects have both of these worlds have declarative nature. In functional forest, we kind of can reference to declarative nature in a way that in any like functional language, we don't write commands to specific like memory mapping where we want to store it. We just set some data structures, which is already an abstraction, and it doesn't mean that we actually define it in a more imperative way. Although also there are like various ways you can write the code, whether it's more imperative or declarative. So they again have partially these features too. So they can be again mapped to one another. And there is one more feature. Again, the YAML file is very like special to the Kubernetes side, so it's kind of the main specific language because there is the need to actually learn how to write these options, what some of the options mean, and how to define them properly in terms of hierarchy and structure. In functional world, DSL would be functional language or some framework constructs which allow to define how you can work with all the objects in this world. So both of them also have some DSLs which are specific to this world. So Alice just followed like one of the tunnels in the factory, and she was thinking that the river that like divided these worlds, although they kind of got into one another because the functional buildings existed in default namespace city, pods running around in the functional forest. So all of these worlds are not that different. They kind of coexist with one another. They help each other in a way, and there is something similar between two of them, because if understanding only one of them, like functional or Kubernetes, it's just easier to like switch and get understanding of another. So Alice was walking in darkness, and when she closed her eyes and opened them, she found herself on the lawn, because that was the moment she realized that she just found the right turn and that she got out of this maze. And this is like the end of her adventure. So, thank you for your attention.